Okay, this video is on 3.1.10, and this is a problem about a basketball player in his 16-year career. And the player claimed he used the steroids strictly for rehabilitation purposes and that they did not give him more power to hit home runs. Sorry, it's a baseball player. It says the data shows the number of home runs the player hit during the first 8 years of his career, followed by the number of hits during his last 8 years. And it wants us to compare parts A through E for both data sets. So let's open up our information. Here's years 1 through 8. And then here's years 9 through 16. And these are the home runs the player hit in those years. So the first, in part A, we want to calculate the mean for years 1 through 8 and the mean for years 9 through 16. So years 1 through 8 are across and years 9 through 16 are across. So I'm going to do this by hand just to show you how you can do small data sets by hand. So for years 1 through 8, you're going to add up the numbers 3 plus 51 plus 32 plus 33 plus 37 plus 21 plus 42, and you're going to divide by your number of data points 1, 2, 3, 4, 5, 6, 7, 8. So once you do that, I believe I got 10 plus, okay, 28.625 for the mean for years. I'd already put this in my calculator, so I was trying to retrace my steps. So you add all these numbers up under years 1 through 8, and you divide by 8 the total number of data points you have, and you will get, for the mean for years 1 through 8, you will get 28.625. And it says round to 3 decimal places, so it's already at 3 decimal places, so that is your mean. Now for the mean of years 9 through 16, let me show you how I calculated that. I added the numbers up for years 9 through 16. I added those data points up. You have 8, and I divided by 8. So the mean for years 9 through 16, I got 44.125. Alright, so that is my answer for part A. For part B, we have to calculate the median. So to calculate the median, the first thing you have to do is order your numbers. So if I wanted to order years 1 through 8, the first number would be 3, then 10, then 21, then 32 and 33, and then 37, 42, and then 51. So now I have them in order, but as you can see, when you have an even amount, your middle would be in between two numbers, because you go down, you have 3, 1, 2, 3, 1, 2, 3. So the median would be right here. Now in the PowerPoint, it says something like, take half of 8 and you would get 4. And 1, 2, 3, 4 would be in between the 32 and the 33 is the way that they want you to do it when you have an even amount. Now, if you have an odd amount, there is a middle. But an even amount, the middle is in between those two numbers. So those two numbers are 32 and 33. So the median for years 1 through 8 would be 32 plus 33 divided by 2, which would be, well, 32.5. And they don't want you to round. So the median for years 1 through 8 is 32.5. Now the median for years 9 through 16, we have to do the same thing. We have to put our numbers in order. Let me make this a little bit smaller here. Okay, for years 9 through 16, our order would be 10, then 30, then 33, 37, 51, 58, 64, and then 70. So our middle would be 1, 2, 3, 1, 2, 3. Make sure I didn't leave anything off. 10, 30, 33, 37, 51, 58. All right. So our middle would be, we actually would have two middle numbers here, or halfway between those two. So when it's, and remember, when it's an even amount, we really don't have a center. The center will be the average of the two middle numbers. Now, if you had a lot of numbers, let's say you had 80 numbers times 0.5, then the half of 80 would be 40. So your median would be right in between 40 and 41. Like our median here is right between 4 and 5, because our index was 4. When it's an even set, your median is going to be whatever you calculate and then the next number above it. Back to what we're doing here, though, we would get 44. So our answer there would be 44. Now for the mode, it's the data point that occurs the most. There's nothing that repeats here, so we don't have a mode. Okay, now the last part, I'm going to erase this for a second, because I want to look at years 1 through 8, and I want to compare the median and the mean. So let's look at what we got for the mean and the median for years 1 through 8. So we got 28.625 for the mean. And then for the median, we got 32.5. So let's look at this graphically. The mean is smaller than the median. So we call this, it's to the left of the median, so it would be left skewed. Let me show you what I mean here. Because the mean is less than the median, if it's less than the median, then it's going to be, the mean's going to be on the left. So the distribution shape is left skewed. Now for the last one, the mean is 44.125 for years 9 through 16. And let's draw the median first. The median is 44. I forgot the mean that quick. 44.125. So the mean is 44.125. That's really, really close. So let's make sure you read the directions. I didn't really set a good example here, but it says, for the purpose of this exercise, consider the mean and median to be approximately equal if their difference is less than 1. Well, clearly, this is less than 1, so we would say that because the mean is approximately equal to the median, then the distribution shape is symmetrical. Now for the last part, remember he's claiming that steroids that he used to rehabilitate himself didn't affect his home runs. Like it didn't make him a better player. Let's look at the data here. Let's compare years 1 through 8 and years 9 through 16. I pretty much could look at it and tell that, yes, he's doing way better in the last 8 years. But if you want to look at the numbers, look at the numbers here. Look at his mean before the steroids. Look at his mean after the steroids. Look at his median after the steroids. So since it clearly the mean and median are much higher, then there seems to be enough evidence to doubt his claim. We're doubting what he said because his home run average did go up and his home run median went up. So this question has a lot of parts to it. And you have to really read what it's asking you to do. And you're working with 2 data sets here, so be careful and make sure you calculate it on the right data set for the question. And then if you have any questions, just please let me know.